1 spoonful, 2, 3. Soon, you're powered up by the energy surge that comes from your meal. But how did that energy get into your bowl? Energy exists in the form of sugars made by the plant your cereal came from, like wheat or corn. As you can see, carbon is the chemical backbone, and plants get their fix of it in the form of carbon dioxide, CO2, from the air that we all breathe. But how does a plant's energy factory, housed in the stroma of the chloroplast, turn a 1-carbon gas like CO2 into a 6-carbon solid like glucose? If you're thinking photosynthesis, you're right. But photosynthesis is divided into 2 steps. The first, which stores energy from the sun in the form of adenosine triphosphate, or ATP. And the second, the Calvin cycle, that captures carbon and turns it into sugar. This second phase represents one of nature's most sustainable production lines. And so with that, welcome to the world's most minuscule factory. The starting materials? A mix of CO2 molecules from the air and pre-assembled molecules called ribulose bisphosphate, or RUBP, each containing 5 carbons. The initiator? An industrious enzyme named Rubisco that welds 1 carbon atom from a CO2 molecule with the RUBP chain to build an initial 6-carbon sequence. That rapidly splits into 2 shorter chains containing 3 carbons each and called phosphoglycerates, or PGAs for short. Enter ATP, and another chemical called nicotinamide adenine dinucleotide phosphate, or just NADPH. ATP, working like a lubricant, delivers energy, while NADPH affixes 1 hydrogen to each of the PGA chains, changing them into molecules called glyceraldehyde 3-phosphates, or G3Ps. Glucose needs 6 carbons to form, made from 2 molecules of G3P, which incidentally have 6 carbons between them. So sugar has just been manufactured, right? Not quite. The Calvin cycle works like a sustainable production line, meaning that those original RUBPs that kicked things off at the start need to be recreated by reusing materials within the cycle now. But each RUBP needs 5 carbons, and manufacturing glucose takes a whole 6. Something doesn't add up. The answer lies in one phenomenal fact. While we've been focusing on this single production line, 5 others have been happening at the same time. With 6 conveyor belts moving in unison, there isn't just 1 carbon that gets soldered to 1 RUBP chain, but 6 carbons soldered to 6 RUBPs. That creates 12 G3P chains instead of just 2, meaning that altogether 36 carbons exist, the precise number needed to manufacture sugar and rebuild those RUBPs. Of the 12 G3Ps pooled together, 2 are siphoned off to form that energy-rich 6-carbon glucose chain, the one fueling you via your breakfast. Success! But back on the manufacturing line, the byproducts of this sugar production are swiftly assembled to recreate those 6 RUBPs. That requires 30 carbons, the exact number contained by the remaining 10 G3Ps. Now, a molecular mix and match occurs. 2 of the G3Ps are welded together, forming a 6-carbon sequence. By adding a third G3P, a 9-carbon chain is built. The first RUBP, made up of 5 carbons, is cast from this, leaving 4 carbons behind. But there's no wastage here. Those are soldered to a 4th G3P molecule, making a 7-carbon chain. Added to a 5th G3P molecule, a 10-carbon chain is created, enough now to craft 2 more RUBPs. With 3 full RUBPs recreated from 5 of the 10 G3Ps, simply duplicating this process will renew the 6 RUBP chains needed to restart the cycle again. So the Calvin cycle generates the precise number of elements and processes required to keep this biochemical production line turning endlessly. And it's just one of the hundreds of cycles present in nature. Why so many? Because if biological production processes were linear, they wouldn't be nearly as efficient or successful at using energy to manufacture the materials that nature relies upon, like sugar. Cycles create vital feedback loops that repeatedly reuse and rebuild ingredients, crafting as much as possible out of the planet's available resources. such as that sugar, built using raw sunlight and carbon, converted in plant factories to become the energy that powers you and keeps the cycles revolving in your own life.